So for today's experiment, we're going to be working with different kinds of solids. You're going to have to go to Blackball and download the lab sheet and data sheet, but the experiment is fairly simple and straightforward, involving a separation of different kinds of solids.
So we find that solids fit into several distinct groups based on what is forming the 3D array of the solid. Molecular solids are only held together by the intermolecular forces, which are relatively weak. That means molecular solids tend to be soft, low-melting materials with the vapor pressures. The ionic solids, on the other hand, are held together by the Coulombic attraction of the different ions, and they really like being in the 3D array. So the ionic compounds tend to be very hard, brittle, high-melting materials. On the other hand, they tend to dissolve well in polar solvents, like water. The metallic solids are held together with metallic bonding, and so they are flexible, and they have melting points all over the place. But they tend not to dissolve in solvents. They can react and go into solution, but it's not going in as the metal ions. And finally, the network solid, being one molecule, is extremely hard. It's extremely high melting, doesn't have any vapor pressure, and basically is not going to be soluble in anything. What we're going to be dealing with today is a mixture of three compounds. The first one is benzoic acid, C6H5COOH. And that is obviously going to be a molecular compound since it's made out of molecules. The next we're going to be dealing with is sodium chloride. And sodium chloride is, of course, an ionic solid. And finally, silicon oxide, basically quartz, in the form of sand. And sand can be considered as a network solid. Not going to be dealing with any metals today. They don't work with our process. So, we have a mixture of those three compounds. And I want to know what percent of the mixture is each of those compounds. And what you're going to do is simple. You're simply going to weigh out a sample into a petri dish to work with. Once you have your sample weighed out on the petri dish, we're then going to start separating the different solids. Since both the ionic and the network solid have no vapor pressures, whereas molecular solids frequently have vapor pressures, one of the ways we can separate the ionic and the network solid from the molecular solid is to just heat it up and drive the molecular solid into the gas phase. And so that's going to be our first step. We're going to put the petri dish on a hot plate and let the benzoic acid sublime out of the sample. Now we do not want to fill the room with benzoic acid vapors. It's not good to inhale the chemicals under any circumstances. And so we're going to place a beaker over the sample, and when it heats up, the benzoic acid will sublime up onto the beaker, and so we'll be able to separate the benzoic acid from our mixture. Once we've weighed the petri dish, that includes both the sodium chloride and the sand at this point, we then have to get those two components apart. And again, the way we're going to do that is simple. We'll simply add water to the petri dish. The sand, of course, isn't going to care about the water. Network solids do not dissolve. But water is a very polar solvent, and so it's a good solvent for dissolving ionic compounds like the sodium chloride. So very quickly the sodium chloride will dissolve. And so we can remove the sodium chloride from the sand by just pouring off the solution of salt water we have created. And now we can get the mass of the sand by simply driving the remaining water off the sample by again putting it back onto the hot plate. Having done that, we have the mass of the sample to start with, the mass without the benzoic acid, and then the mass of the sand in the sample. And the sodium chloride, of course, is whatever was left of the sample. To start our experiment, the first thing we have to do is weigh the Petri dish. Zero the balance to make sure it's zero. And put in our first dish. And write down the weight of that dish. Now we need to weigh out between 1.2 and 1.5 grams of our sample. So that means we're going to need something between 59.7 and 60. So that's the mass of the Petri dish and our first sample. For our second sample, we are again going to have to first weigh the Petri dish and then weigh out our sample. The balance is reading 0. And there's the mass of our second Petri dish, 57.478. We now need to weigh out between 1.2 and 1.5 grams, so that'll be between 58.6 and 58.9. So there's the mass of our next sample and its Petri dish. We can now transfer our two samples to the hot plate. And observe what happens. After heating several minutes, you can see some of the benzoic acid has now started to sublime up onto the sides of the beaker. You can see the white material accumulating, and some of it you can see circulating in the air, sort of like a snowstorm in the beaker that we're using to collect it so that we don't fill the room with the benzoic acid vapor. After 10 minutes, all the benzoic acid has sublimed up into the beakers and been left behind. Now we can take the samples off and let them cool down to room temperature so we can get a mass of the salt, sand, and Petri dish without the benzoic acid present. Looking down on the two samples, we can clearly see that the beakers have the benzoic acid in them, and we have the salt and sand still in the original Petri dishes. We now, having let them cool off, can go and weigh the Petri dishes. So, our first sample has cooled off enough to weigh. First we check that the balance is zeroed, and then we can weigh our sample. So that is the mass of our first sample with the Petri dish, the salt, and the sand, but no benzoic acid. Our next sample has cooled off enough to try and get the weight. So we check the 0 on the balance. It's reading 0. And we can weigh the mass of our next sample, the sodium chloride, the salt, and the Petri dish. And there's our second reading. We're now going to wash our sand and salt with a small amount of deionized water. And decant the water into a convenient beaker, trying to be careful that we don't lose any of the sand in the process. Add some more water to do a second wash. To make sure we have gotten rid of all the salt. And again, decant as much of the water as we can. Without losing any of our sand. That's as much water as we're going to be able to pour off. Now we're going to have to take the sample and put it on the hot plate.
We've now washed our second sample in a similar fashion to the first one, gotten all the water off of it we can without losing any of the sand. We now have to put it onto the hot plate.
Our two samples have been sitting on the hot plate for 15 minutes. All the water has been driven off. All we have to do now is take them off the hot plate, let them cool, and we can weigh them again and find out how much sand we had in each of our samples. Our sample is now cooled down enough that we can weigh it. So first we zero the balance to make sure it's zero, and then we put our sample on the balance. And there is the mass of our Petri dish with just the sand from our unknown sample in it. So the sample has now cooled down enough that we can weigh it. So we check the zero on the balance. And so that's the weight of our sample with just the Petri dish and the sand from our original unknown.
And that concludes today's experiment. You have to fill in the data, do the calculations, and turn in your lab report. Go have a nice day.